So, equations of lines. I think it's really important to keep track of the fact that all of our equations, all the different forms for an equation of line, basically come from one concept, and that is the slope between 2 points, A and B, on a line is constant. So let's suppose I've got a line with points A and B on it. If we again look at slope, slope is going to be delta y over delta x. And for something to be, for a curve to be linear, it means that no matter what points we are, no matter where we are in a line, if we look at delta y over delta x, that's going to be a constant. And again, from the previous unit, if I have delta y over delta x being a constant everywhere, I get similar triangles by side angle side, which means my two angles here are congruent, and which means I've got a constant rise, if you will, or a constant fall. So again, looking at that idea of a constant slope, the slope then is delta y over delta x, and we said that delta y, y2 minus y1 over x2 minus x1. That is the fundamental idea that you need to find an equation of a line. So if you're asked to find an equation of a line, given a point on the line and the slope of the line, you always want to call a general point on the line x comma y. So again, to keep the slope constant, the change in delta y over the change in x is going to give you your slope, in this case 3/4. That right there is an equation of a line. Now, your textbook defines that as the point-slope form, and that's true. You can define things however you want. However, I would call that the slope form, and then to get to the point-slope form, the one that you've seen in your previous algebra and geometry courses, if I take that equation and multiply both sides by x minus 2 quantity, I get y minus 3 equals 3/4 x minus 2. And that's your familiar point slope. Why do we call it point slope? Because we can read point 2 comma 3 and slope 3/4 off of it. So again, you should be able to write an equation of a line given a point in the slope by using the definition of slope, and then multiplying perhaps to clear a denominator to get your familiar point slope form. And then if you're given that point slope form, you should recognize and talk about what's the slope and what's a point on the line. So let's suppose I've got a point slope equation for a line, and I then want to write in what's called standard form, and or general form. General form, ax plus by equals c. All I need to do is algebraically manipulate this and turn it into that. So I can do that, again, by just doing a little algebraic manipulation. So if I multiply through the 3/4 and move the 3 to the other side, I would get y equals 3/4 x minus 3/2 plus 3. And then I could move the 3/4 x over to the left side, negative 3/4 x plus y equals, combine the 3 and the negative 3/2, that would be, let's see, 3/2. And now, am I in the form of ax plus by equals c? Indeed I am. A is negative 3/4, b is 1, and c is 3/2. Perhaps if I don't like fractions, what I could do is multiply both sides by 4, and I would get negative 3x plus 4y equals, let's see, multiplying both sides by 4, I would get 6. And there again I'm in each case I'm in what's called general form. Now I also, back here when I started off in point slope, y minus 3 equals 3/4 x minus 2. I could have gone ahead and multiplied by 4 just to start with, just to eliminate fractions. So 4y minus 12 equals 3x minus 6. Put the x's and y's on one side, negative 3x plus 4y equals 6, and I wind up getting to the same place. Now your text talks about the intercept form for a line. If you can write a line in the form of x over a plus y over b equals 1, a and b are going to be x and or y intercepts. And let's think about why that might be true. Let's suppose we let y equal 0. That means that x over a would have to equal 1. For x over a to equal 1, x would have to equal a. And conversely, if x were 0, for y over b to equal 1, that means y would equal b, and therefore I know the points a0 and 0b are going to be on that line, x over a plus y over b equals 1. So I can visually, if you can remember this, and I don't think it's that important to remember the intercept equation, because you can always find x and y intercepts by direct substitution, x equals 0 and y equals 0. But if you remember it, it's kind of neat to see. How can we change and look at an example and find and put the line into this form? Suppose we had 2x plus 3y equals 7. Well, the key is to put it into the intercept form is I got to get that constant equal to 1. And the way I'm going to do that is simply divide both sides by 7. So then I would have 2/7 x plus 3/7 y equals 1. And then what I'll do is lose the picture. Come on, get back here. There we go, got it back. So what I want to do to get in that top form is I need to have an x and a y in my numerators. And so to do that, if I've got 2/7 x, if I put that into the denominator as 7/2, that's the equivalent of 2/7 x, and the same thing for y, 7/3 equals 1. So again, you can go from slope-intercept to point-slope to, you can manipulate algebraically amongst all the various forms for an equation of a line. Now, if you're going to graph a line, draw yourself axes. Put some arrows on the positive x and positive y axes. Ideally, you're going to label your axes, x and y. You want to identify important points on a line when you graph it, and the important points are the intercepts. Label them directly on the line. So in other words, if I've got a line that does this, you're going to want to find and label those 2 points. And that also then gives you a scale on your axes. So if you're going to graph a line, find and label the intercepts. How do you find those intercepts? Pretty simple. If you're finding an x-intercept, you let y be 0. If you're finding a y-intercept, you let x be 0. You plug in 0 for x or y and solve for the missing coordinate that you're trying to find for the intercept. And again, like to kind of show you where you're going. This is pre-calculus, but as often as possible I'm going to bring up calculus topics. What we're going to be interested in one area in calculus is we're going to be interested in finding the equation of a line tangent to a curve at a given point. For example, at this point right here, I might want to find the equation of the line tangent to the curve at that point. I also might want to find the equation of the normal line to the curve at that point, which is going to be the line perpendicular to that tangent. Now, obviously, how do we find the slope of that tangent? If I'm given some formula, some function rule for the curve, well, that's calculus. But it's going to be assumed when we get there that you're going to be able to manipulate and be very familiar with finding equations of lines and knowing what slopes mean, positive or negative slopes, to find said lines. And then there's going to be applications for what the slope of that tangent line represents there for that specific curve.